Question number 60 is going to be analyzed similar to question number 59, and we're going to use the same principles. But we need to kind of add on one other detail. So when we look at this option A, we have 1 over x squared plus 1. So this is going to behave like a 1 over x squared function as we go to infinity. So it's going to have finite area kind of in there. But it's going from 0 to infinity, so we need to know what's happening near 0. Now, in this case here, we need to have an understanding what this graph looks like. This graph at 0 is going to be equal to 1, and it's going to kind of go like this. It's going to be our max point, and it's going to go down, and this end is going to behave like 1 over x squared. So this area is pinched off here, so that area is finite, and we know that's for some arbitrary point A going this way. This is also finite. That means we have finite area, and so this is convergent or converges, so we're going to eliminate that one. Looking at the 1 over x cubed, sorry, cube root of x, between 0 and 1, we know that it's going to be this situation over here where we have a root function in the denominator, and the area is against the vertical asymptote, and that's going to be finite area, so that is convergent. For 0 to infinity over x cubed plus 1, well, this one here is going to behave again like an x cubed function, so it's going to be as x goes to infinity, so it's going to have finite area. And what's happening near 0 again is going to be that it's going to look similar to the 1 over 1 plus x squared on the right hand side anyways. On the left hand side we will have something slightly different, but on the right hand side it's going to be the same, and from 0 to infinity this is going to be finite or convergent. Looking at D, this is an exponential function, so it's going to pinch off to 0 quicker again on this tail when we take a look at the tail of this function, and at 0 we're going to have 1/2. Okay, so it's just going to be similar to this graph again, but it's going to go down to 0 much quicker than all the other ones. So this one again is also going to have finite area, and so that is convergent. So the last one is that this by default must be the answer, but let's analyze it. So it's going to be this picture over here. It's going to be a root function in the denominator, so some arbitrary point A, so in this case it's going to be x to infinity. We're talking about this red area here, and we've established that that area is infinite for those types of graphs.